Welcome Algebra 2 students. Today we're going to start looking at factoring. We have a lot of different types of factoring. Our first task today is just to look at basic trinomial factoring. To do that we have to remember how to FOIL. So foiling stands for first, outside, inside, last. And it's really just a way of multiplying two binomials. Okay? And foiling, we take the first term, so we take x times x and multiply those together, which gets us an x squared. Then we do outsides, which would be our x from the first parenthesis and our 2 in the second parenthesis. So we end up with 2x. Then we do insides, which are the two closest together, the 4 and the x. We multiply those and get 4x. And then our last piece are the two constant numbers, the 4 and the 2. Multiplying those gets us an 8. And then if we combine like terms, we end up with x squared plus 6x plus 8. Now when we factor, we are doing the reverse of foiling. So first consider that our x squared basically came from the first term in each. So to make an x squared, we needed an x times an x. Then remember that our constant 12 here came from multiplying the last two numbers. So this was first, and this is last. So we need two numbers that multiply to give us a 12. And we have some options. We can do 1 and 12, 2 and 6, 3 and 4. We could also use the negative versions of those. If they're both negative, they would still multiply to be a positive 12. And then the last piece, in order to figure out which of these three options really works, we look at that middle term. And we consider the connections that were used to create that. So this middle term came from combining inside and outsides. So we look at what we get for an inside, what we get for outsides when we FOIL, and those have to add up to that middle term. So putting a 3 and a 4 in our parentheses, choosing this option, gave us two factors that are going to combine and add up to that 7x in the middle. Remember that quadratics come in the form of ax squared plus bx plus c. When your a term is 1, or when you really don't see a number in front of it, it just looks like a plain x squared, it's always going to break down into two factors that start with an x. And then we are simply looking for numbers that multiply to be the last number, the c value, and add up to our b value. So they have to multiply to be c, and they have to add up to b, as long as your a value is just a 1. All right, let's try a few. So the best way to get better at factoring is just to practice, practice, practice. So we're going to start with some where our c value is positive. Notice that we have a single x squared, a 1x squared. So right away we can think of breaking this into two factors that contain an x. Then we look at our constant. We need two numbers that multiply to be 20. So let's look at our options. We could have 1 and 20, we could have 2 and 10, or we could have 4 and 5. Then we look at those pairs and say which one will also add up to this middle number, to the 9. And since 4 and 5 add up to 9, we're going to choose that pair. So we need a positive 4 and a positive 5 in our factors. And then you can always FOIL this back together to double check. Okay, so for example, x times x would give us the x squared. The insides and outsides, we get 4x plus 5x will get us that 9x. And our last term is the 4 times the 5, which gets us the 20. All right, let's try another one. Again, we're starting with a plain x squared, so we know we're going to need factors that start with an x. We need two numbers that multiply to be 25. So we could do 1 and 25 or 5 and 5. And then we need a pair that adds up to the 10, in this case the 5 and 5. Now because both factors are x plus 5, we could shorten this and just write it as x plus 5 squared. That indicates that we have two identical factors. Now the first two examples, everything was positive. So we really were just focusing on our positive options. But in the second two examples here, notice that we have a positive c value, but we do have a negative b term. And the only way to have things multiply to be positive, but add up to be negative, is to have two negative numbers. So again, our x squared, we're going to split into x and x. And then we're going to look at values that make a 72 when we multiply. There's quite a few of them. We could have 1 and 72. We could have 2 and 36. We could have 3 and 24. We could have 4 and 18. We could have 6 and 12. Or we could have 8 and 9. All of those pairs multiply to be 72. If we make them all negatives, they're still going to multiply to be 72. But now when we look at adding our numbers together, we can see that they would add up to negatives. We need them to add up to be a negative 17. Our first pair adds up to negative 73. Our second pair adds up to negative 38. Our third pair adds up to negative 27. The only pair that's going to add up to negative 17 is the 8 and 9. So we need an x minus an 8 and an x minus a 9. Does not matter which factor you put which number in. All right, go ahead and pause the video and try this one, and then turn it back on. All right, once again, we are going to split up our x squared into x and x. We need numbers that multiply to be 17. We only have one pair, 1 times 17, but we could have their negative options, both being negative. And the pair that adds up to negative 18 would be the bottom one here. So you should have an x minus 1 and an x minus 17. Our next set of questions, notice that our C value is negative. What this really means is that we need to look for factors of 15 where we need one positive and one negative. So we're going to think of it that way. If we have one positive and one negative, then we add them up. We still are looking for them to add up to this middle number. All right, so our x squared again is x and x. To get a negative 15, we could have a negative 1 and a positive 15, or we could have a positive 1 and a negative 15. We could have a negative 3 and a positive 5, or the reverse, a 3 with a negative 5. And now again, we're trying to find two numbers that add up to negative 2. Our first pair adds up to 14, and the second one, negative 14. Our next pair is going to add up to 2, and the bottom one adds up to negative 2. That's the one we want. So we need a positive 3, so one of our factors needs to be x plus 3, and one has to be x minus 5. All right, for our next one, we're splitting up our x squared. We're looking for numbers that multiply to be negative 18, so negative 1 and 18, or its reverse. We could have 2 and 9, with one of them being negative, or we could have 3 and 6, with one of them being negative. We want it to add up to a positive 3, so we would need this pair, negative 3 plus 6. So we need x minus 3 and an x plus 6. All right, let's try one more, and then I'll give you time to try the last one here. To get a negative 13, we could have negative 1 and positive 13, or positive 1 and negative 13. We're trying to have it add up to a positive 12, so this top option is what we need. So we're going to have an x minus a 1 and an x plus a 13. Again, it doesn't matter which order. We could have just as easily written it like this. Either one is fine. All right, go ahead and pause the video again and try this next one. All right, splitting up our x squared, and then looking for factors that make negative 6. Negative 1 and 6, or the reverse. Negative 2 and 3, or the reverse. We want it to add up to a positive 1, so we're looking at the pair negative 2 and 3. So you should have an x minus 2 and an x plus 3. Now, it doesn't matter the order. What does matter is the sign has to go with the right number. So if we flip this around, we could write x plus 3 and then x minus 2, but the 3 has to be positive and the 2 has to be negative. All right. There's one other type of factoring that we're going to look at today, and that is that idea of a greatest common factor. If there is a number or a variable, or both, that's common to all of the terms, we want to pull that out first. Okay, so looking at this first example, you will notice the numbers 5, 45, and 90. They don't all have an x with them, so we can't pull out any variables, but we could take a 5 out of everything. So let's go ahead and divide a 5 out of this. We'd have x squared plus 9x plus 18. Now that 5 is still a factor. We're going to leave it in front. We're going to split up our x squared again. And now we need numbers that multiply to be 18. So 1 and 18, 2 and 9, 3 and 6. We could also have both of them be negatives, but since our middle term is positive, we are going to stick with the positive numbers. We want it to add up to 9, so we're going to choose the 3 and the 6. So our answer has to include all 3 of these pieces, the 5, the x plus 3, and the x plus 6. For our next example, notice that we are starting with a negative 1x squared. The 8 at the end doesn't have any x's, so we can't pull any out. But we could pull a negative 1 out. And what that's going to do is it's going to make that x squared positive. The 6x becomes negative, and the negative 8 becomes a positive. It's much easier to factor when you have a plain x squared, so we can split it into x and x. So we're going to pull that negative out front. Then we're going to look for numbers that multiply to be 8. So 1 and 8, negative 1, negative 8. Sorry, we're trying to get negative. No, we're trying to get positive 8. All right. So 1 and 8 are both negative. 2 and 4 are both negative. We want a negative 6 in the middle. So we are going to need this last option I listed, negative 2 and negative 4. All right. Our last couple, you'll notice that all of the terms contain a variable. So if that is the case, we want to pull that out as well. If there's a number that's common to both, we'd pull that out as well. So for this one, notice that 3 and 15, we could take a 3 out of both of those. An x squared and an x, the maximum number we can pull out is a single x, since this last term here, the 15x, only contained a single x. What we have left after we do that, think of think of dividing both of these pieces by a 3x. The first piece just leaves us an x. The second piece leaves us a negative 5. And there's no more x squareds that we need to break apart, so that question is finished. On our last example, 3, 18, and 15 all have a common factor of 3, so we're going to pull that out. And notice that they all have an x in them. Since this is my smallest power, that's what's going to limit me. I can pull one x out. If I divide every term by 3x, I'm going to have an x squared. I'm going to have a 6x. And I'm going to have a 5. And now we do still have an x squared, so we're going to try to break that up a little bit more. X squared splits into x and x. The 5, only factors of 5 are 1 and 5, or both negatives. Since our middle term has to be a positive 6, we want to use the 1 and 5. So my final answer would have 3 factors, a 3x, an x plus 1, and an x plus 5. All right, your homework today is going to be a Delta Math assignment. Let me know if you have any questions.